Here in problem number 22, we're given a function and we're asked to find its absolute maximum value. A couple things to think about. When you hear absolute value, we usually think of a closed interval, only they don't give us a closed interval now. So we usually would have to consider the endpoints as well as any critical numbers as candidates for a location of an absolute extreme value. But since they don't give us an interval, we'll just assume they're talking about the entire domain of F, is what we should consider. Talking about that, remember that the domain of a natural log function is just any x value or any input value that's greater than 0. We're talking about extrema, we should consider derivatives. Let's start by finding f prime of x. We use the quotient rule. We go low d high minus high d low all over low squared. And we can clean this up a little bit. We see x times 1 over x, just 1. Natural log of x times 1, just natural log of x, all over x squared. So we're gonna find some critical numbers now. Critical numbers are found when f prime is 0 or when f prime is undefined. Okay, let's start with finding what makes f prime undefined. When the denominator of a fraction is 0, the fraction is undefined. So x equals 0 makes this function undefined, this derivative function undefined. However, x equals 0 is not in the domain of our natural log function, which is part of f. So x equals 0 is not going to be considered a critical number. Now let's see what makes f prime equal to 0. Well, the numerator we'll set equal to 0. And now with algebra, we'll just solve. If you remember your log properties, we can find x mentally now. If not, we have to go through the steps. Whereas each side is a power of e. And you'll get e to the first power is e. And e to the natural log of x is just x. So we have one critical number to consider. We just shrunk some of the scratch work to make more space for us to continue. All right, so we've got one critical number. Remember, our domain is only for positive x values, so we don't have an arrow on both ends of our sign chart. And of course, we labeled our sign chart. Now let's continue. Now let's pick a number in the first region here, say x equals 1. Then f prime of 1 is going to be 1 minus natural log of 1 all over 1 squared. The natural log of 1 is 0, and 1 squared is 1. So f prime of 1 is just 1, positive 1. So we know f prime is positive in this first region. Now I'm going to make some more space. Pick a number in the second region. And since we're not allowed to use a calculator, let's use a number that's going to be easy for us to work with. I don't know. How about e squared? E squared is going to be larger than e. So we're going to find f prime of e squared. It's going to be 1 minus natural log of e squared all over e squared squared. This is really 1 minus 2 all over e to the 4th power. Or negative 1 over e to the 4th power. But e to the 4th power is positive, so negative 1 divided by a positive number is going to give us a negative value. This concludes that there is, in fact, a maximum value at x equals e. Remember that the value of a function is the y value, so to find the absolute maximum, we'll need to evaluate f of e. Going back to the original function f. Good Lord. There we go. And f of e is going to be the natural log of e all over e. Remember, natural log of e is 1. 1 over e is our absolute maximum value, which matches option letter B. Hopefully this video was helpful. Thank you for watching.